What if designers could easily find out what impact their design has on the environment and change parameters to improve the eco-credentials of their product? By combining the power of simulation of discovery with material intelligence in Granta MI, we have the tools to achieve it. Let's have a look at this track suspension in Ansys Discovery. For the purpose of this study, we'll focus on A-arms, the upright, and the spindle. So let's hide the rest. We have set up the model with its boundary conditions. These parts are currently made of structural steel S275J. An initial simulation gives us in seconds a safety factor of 2.8, a mass of 18.3 kilograms, and a climate change indicator of 31.5 kilograms. We can search for an alternative material to lower its climate change indicator while retaining or improving its mechanical properties. For this, we have access to Granta MI reference database and will be using MaterialUniverse dataset, which contains complete and comparable data for over 4,000 commercially available engineering materials. Each datasheet represents the technical, economic, and environmental performance of the material. In another view, we can visualize a graph of yield strength versus climate change for a typical grade of material and perform a material selection. A maximum of $1.5 per kilogram of material, a yield strength similar or better than the reference material, we also want it to reasonably resist to crack propagation, and for this material to be formed by stamping. A bit less than 200 materials have passed the criteria. A number of them have a lower climate change indicator per kilogram of material produced, that are oil quenched and tampered, which we'd like to avoid. This low alloy steel could be an interesting option. Looking at the different property, we can compare materials and go more in details by studying the alternative material datasheet. Once a choice is made, the material can be assigned to the parts. In this case, we point to the same dataset we did our selection upon, MaterialUniverse, and find our selected material by typing it in. The simulation results are updated, as well as the environmental indicators. We can see that this material increases the factor of safety from 2.8 to 3.88, keeps the same mass, while reducing by 14% the climate change indicator from 31.5 kg to 26.5 kg of CO₂ equivalent. The next step could be to try with another material from the selection, or alter the design to reduce the mass while watching the safety factor, or for you to use it with your own designs.